This is 6.3, solving equations using multiplication or division. So we're going to be using the multiplication property of equality, and that says when you multiply each side of an equation by the same non-zero number, the two sides remain equal. So if I have an equation, I can show that with 12 over 3 equals 4, and if I multiply each side by 3, I'm going to get the same, it's not the same, but it is an equivalent true statement, meaning 12 equals 12. And I can also do that with variables. If I have x over 4 equals 10, and multiply each side by 4, I'll get x equals 40. So I know that this is equivalent because of the multiplication property of equality. I did the same thing to each side, which keeps my equation true. We also have the multiplicative inverse property, and that says the product of a non-zero number, n, and its reciprocal. Reciprocal means you take a fraction and you flip it upside down. So I have n and 1 over n, and when I multiply those, my answer is 1. I can show that with numbers, and 5 times 1/5 is 1. That's because I would turn this 5 into 5 over 1, and multiply by 1/5. And when you multiply fractions, you multiply straight across the top, straight across the bottom, and that will equal 1. So let's solve this example. X over 2 equals 12. I'm going to take this 1/2, so this is x times 1/2, which reduces to x over 2. I'm going to multiply each side by 2, and I get x equals 24. This is using the multiplication property of equality, and using the inverse of 1/2 to get x by itself. In this example, I have 3/4 x equals 15, and here I have my fraction out in front. So I multiply by the reciprocal, so I take my fraction, 3/4, and I flip it to be 4/3. That equals 15. What I do to one side, I have to do to the other side, and so I'll have x equals 60, because 5 times 4 is 60, 1 times 3 is 3, and then reducing this, I get x equals 20. Let's try another one. 2/5 x equals 6. Using the reciprocal and multiplying on each side, I will get x equals 30 over 2, because 5 times 6 is 30, and 1 times 2 is 2. 30 over 2 is 15. So that was all of multiplication. Now let's look at division. So we have the division property of equality, and that says when you divide each side of an equation by the same non-zero number, the two sides remain equal. So if I show that with numbers, 10 times 2 equals 20, and dividing each side by 2, I get 10 equals 10. Then I could show you with a variable, and I have 3x equals 18. If I divide each side by 3, I get x equals 6. I want to make sure I'm choosing the number that will leave x all by itself. So let's solve 80 equals 8x. To get x by itself, I need to divide by 8. So divide each side by 8, and x equals 10. This is using the division property of equality, and we know that in math, whatever you do to one side, you must do to the other. If I have 12x equals 72, dividing each side by 12, I get x equals 6. If I have 7x equals 56, and I divide each side by 7, x equals 8. I could also do it again with a fraction out in front, and I'm going to multiply by the reciprocal. And I get x equals 36 over 2, which is x equals 18. And I have a little bit of a word problem. It says the area of the screen is 3,200 inches squared. The width is 40 inches. What is the length? So with word problems, it's always a good idea to draw a picture. So I have my rectangle to show my screen, and I have 3,200 is the area, and the width is 40. I also have to know that area is length times width. Using the information that it gives me, I'm going to plug that in, and I get 3,200 equals L times 40. I'm going to be solving for L because it asks what is the length. So dividing each side by 40, I get 80 equals L.